Hello and welcome everyone, and thanks for joining us today in a new episode of Let's Talk About Data Show. My name is Ibrahim Amara. I'm a database specialist solutions architect here at AWS, one of your regular hosts, and I'm based out of London. Today it's Monday, a new week, a new topic, and as usual, data related one. And for today, we have an interesting topic to discuss where we are going to talk about how you can accelerate the DynamoDB modeling with AI. And for that, I have Kevin and Lee joining me today to discuss this topic. And please allow me to ask them to introduce themselves first. So, Kevin, would like to go first?
All right. Yes, I'm Kevin Willis. I'm a product manager on the DynamoDB team here at AWS, and I've been working with Lee, who you'll meet here in a moment, for several years on how we can enhance DynamoDB. So we're happy to chat with you today about some AI capabilities we're working on. Lee, did we lose you?
I know what's going on today. Even my my internet has given me hard times today, so I know what's going on. But yeah, Lee, yeah, okay, you switched to the other camera
I
now.
did. I did. Hey everyone, my name is Lee Hannigan. I am a specialist solutions architect with DynamoDB, and like Kevin just said, we've been working extensively on the developer experience and how users of DynamoDB can help them to data model more effortlessly, and that's what we want to show you today.
Perfect. And also, we have Jeff, our producer today. He's in the chat, will be helping us. So if you have any questions, any comments, please feel free to send them through, and then we will be trying to answer those questions. So, okay. So let me first start, Kevin Lee. When we're talking about the modeling of a DynamoDB tables or DynamoDB solution, so what are the usual steps that you go through in order to come up with a DynamoDB solution or a DynamoDB design? And that, because I'm asking that because I want to know why do we need an AI behind that? Is it that complex, or it's different from the what we are used to? Someone like me from a relational database background, is it that different from relational databases?
Yeah, good question. Yes, it is. It is different from relational database. If you think about data modeling for a relational database, you have a systematic approach. You take everything through a normalized approach, take everything to third normal form, and then you have your your data layer, and your access patterns can change over time. If we think about data modeling for NoSQL, and specifically DynamoDB in this instance, we think about our access patterns first, and we work backwards from there. So it's a very different approach, and we denormalize the data instead of normalizing it. And I suppose, in essence, data modeling for NoSQL, sometimes we like to say it's more of an art than it is a systematic approach. If you give 5 experts a certain application, your chances are those 5 experts will all have a different data model. Each of them will work quite well, and maybe just one person has a different take on it than the other. So it's not like a one size fits all usually. And we tend to say that data modeling from NoSQL it's iterative. You will start out with one model, and that may evolve over time. So that sort of iterative approach is what this AI is going to help you with.
Okay. Before we go deeper, we have a couple of viewers here. We have AP Mike from UK, and I'm here on bike, so only listening. Please be careful. Okay, so when you're saying that it's iterative, so how do you start? Do you start by, because when you were saying that for the relational database, you have some kind of systematic approach for that. You make it sound like it's an easy job. For our viewers, it's not that easy.
Yes.
I've been doing that for a while. It's not that easy, but I believe it's compared to the DynamoDB. You need a different approach. So you start, of course, I believe, by getting the requirements from the or the customer or the entity that you are building the solution for. And then based on that, you start by thinking about the tables that you're going to provision, and mainly the indexes. I understand that the indexes, they play a major role in the performance as well in DynamoDB.
Yeah, so if you think about a typical user that's maybe trying to adopt DynamoDB, maybe they want the predictable performance, or maybe the no overhead and management and things like that. So they can be coming from a various different source. They could have a relational source. They might be using some other self-managed NoSQL source. But
Mm-hmm.
the first step that they have to do to adopt DynamoDB is they have to understand it. And to understand it, you're going to have to go through pages and pages of documentation. You're going to have to figure out how things like indexes work in DynamoDB, how that differs from an index in a relational world, for example. What's a partition key? What's a sort key? So there's a lot of kind of steps along the way for a user to understand how to model data in DynamoDB, and that would be some extensive learning through documentation, through videos on YouTube, for example. So it's a slow process to kind of first of all get what you need to understand about DynamoDB before you can actually start data modeling.
Understand.
Then, if you're coming from a relational world and you're very used to normalized data, it's this kind of mindset shift that you need to think about. It's very tough in the mind to think about, hey, I can store duplicates now and things like that. So it takes a little while for it to click, but once it clicks, and typically I see this quite frequently when I work with customers, is once it actually does click, everything else is streamlined. So when they learn the basics and they've had an attempt at modeling in DynamoDB, they've made 1 or 2 data models, now it starts to make sense to them. But what we're trying to cure here is that initial hurdle.
The firstly, I was going to ask Kevin about that. So this is the give the someone who is not really just, I'm a developer. I don't want to go all through that. I need a solution there to store this kind of data, and that's it. I don't want to go through tons of documents to understand what's going on and how to optimize all of that. So I believe, Kevin, in this case, a solution like this will solve a problem like that, give them a fast start.
Yeah, I think so. I want really quick to add to what Lee said a moment ago is if you are familiar with a relational database, even if you're going from one to another, you have knowledge that kind of translates, right? Under this NoSQL umbrella of databases, even if you have knowledge about one NoSQL database, it doesn't necessarily translate to DynamoDB, because when you look at NoSQL databases, you have different types like key
Exactly.
value, wide column. And then even then, if you zoom in on an individual database, it has different features. And so you have to take your access patterns and figure out this new paradigm of modeling, but you also need to know the capabilities and features of the NoSQL database that you're using so that you store your data properly, you leverage these features properly. So you might spend a lot of time reading our documentation, learning about all the various features we have. And in the end, some of them you might not need to use, but you don't know that until you get to the end, right? And I think a tool like this can help give you a quick prototype design given your application access patterns. And that kind of gives you this map of where you should start to look now. So you get a little bit of a head start that way.
Perfect. Thanks a lot. And back to you, Lee, again. So what are the most common mistakes that you're seeing people are doing, or customers are doing, when they are designing the DynamoDB tables?
Yeah, I mean, probably the first one is trying to, especially users coming from a relational source, they're trying to replicate what they have on the relational source in DynamoDB. So, for example, you might have some application that call it an e-commerce one, and you have 5 tables in your relational system, and you do joins across those tables, and everything works quite well. Now you want to adopt DynamoDB or any other NoSQL database. You try to replicate those 5 tables into DynamoDB, and suddenly you realize, hey, I can't do joins. So a NoSQL database like DynamoDB doesn't join data. What we want to do is we want to model the data in such a way that we pre-join the data, and that's what we're calling the denormalized approach. So that those 5 tables could become 1 table in DynamoDB, could become 2, could become 3. And figuring that out is sort of the art of the data modeling.
Exactly. It's yeah, when you're talking about it like that, and again, someone with the mindset of relational database like me, they're saying like, no, why are you talking? It's awkward, a bit awkward that, yeah, no, it's what we have been told for ages, that each data, each table has that unique values, and then you start creating those relations and all of that. So, but it makes things sense if you map it to maybe to the data warehouse schemas, for example. You also denormalize again, and then in order to do that. And we have actually a question from Tiger Panda, or a comment. I've been using AWS Amplify and think it lets me define data schema and deploys a DynamoDB and app sync for me. It works really well. So could I believe it could work well, but we are talking about here about a scalable product or a scalable solution that when you add more data, then it will not impact the performance of the application itself, right?
Yeah, and that's the reason that users usually go to DynamoDB, is they want that predictable performance no matter the scale. So the way you do the data model in DynamoDB, it ensures you get that predictable performance. So, for example, if you have 1 megabyte of data or if you have 1 terabyte of data, you still get the same response times. It's predictable. If you've done that in a relational database where you had 1 megabyte or 1 terabyte, your times are the response times are going to be drastically different.
Exactly. Yeah. Okay, perfect. So back again to the solution itself. We are talking about a solution that can help the developers or whoever is trying to create a design pattern or a solution on a DynamoDB using AI. And for that, you are using MCPs. And my understanding about MCP, it's a framework to standardize how you are integrating with the other integration points, with the AI tools and the other integration points as well. So why you are using MCP in this solution?
Yeah, I'll start, and maybe Kevin can fill in some of the context there as well. So, model context protocol, it's a way that you can expose your AI agents to different things, be it endpoints or your data in such a way. We sort of abuse the MCP a little bit in the terms of that we're not exposing endpoints. We just want to provide context, and that context is basically made up of years of DynamoDB expertise condensed into context files that steer the AI in the right direction, that these experts believe that the way the data modeling should be done. We initially started out when we thought about, hey, we can use this AI to help users data model in DynamoDB. And we took a couple of other approaches. We built a web tool that we started using internally, and that worked quite well. And we built some other tools. And then we realized that, hey, almost every customer in the world right now is using some sort of co-pilot for their workloads. Wouldn't it be great if we could provide a way to give them, no matter which AI tool they use, rather than forcing them to use just one? So, for example, you might have a large corporation that they're only allowed listed to use one type of LLM. That's what their business says, that you must use this one. And if we provided our tool as a website or a web endpoint, then we would be forcing you to use ours, and maybe you're not allowed listed for that. So we thought, if we can build this in MCP, it means that these users can use this no matter which LLM they're allowed, and also no matter which Copilot, or whether they're using VS Code or Kiro, Windsurf, Cursor. Doesn't matter what they use, they get to avail of this expertise right where they work.
Yeah.
Okay.
Yeah, to add to that, I think, if you kind of think of it like, if you're using Kiro, Amazon Q, Cursor, Copilot, these are AI agents, right? And
Hmm.
oftentimes you've got your chat window open and you might be working through fixing an issue or designing a new feature. It's like, how do we get into that chat interface so that right in context to what you're doing, you don't have to switch to use another tool, you don't have to use another model, to Lee's point, but right there at the right time, based on that conversation, the AI agent that you're using it knows which tools it has access to through MCP. And so through that, it just looks them up in natural language, essentially, right? Like, okay, we're talking about DynamoDB data modeling here. I've got a tool for that. Let me use it. And so, yeah, for us, this is kind of a knowledge base. And another exciting point of this is that, as we continue to improve this or launch new context to this knowledge base, your AI agent is immediately aware of that. So that's an exciting user experience. So that had a lot to do with why MCP.
Yeah.
Perfect. So even if there is like a new feature or something like that added to the DynamoDB that can impact the design pattern, then it will be integrated or incorporated into that, and it will be made readily available for the end users as well.
Yeah.
Yeah.
Um,
Yeah, so I think the point is we're not waiting on the LLMs to become up to date. So you might be
Yes.
using an LLM that could be 6 months out of date. If a new feature comes into DynamoDB, then we'll automatically add that to the context of the MCP, and that will be able to steer the data model. In this instance, we're talking about data modeling. So if something were to change, then it would be automatically reflected rather than having to wait for the LLM to come out with a new version.
I think a kind of a funny side tangent on that is like I've been on calls sometimes where a customer might tell me, I wish we had a feature that does this or that, right?
Mhm.
And I feel great because I get to say, you know what, good news, we actually do that, but it came out about 6 months ago or 12 months ago, and there's a lot of documentation to sift through to understand or find those things as they come out. So, great experience would be the next time I open up my AI agent and I start to have a design conversation, if it's aware of these features and it says, hey, guess what? As of such and such date, DynamoDB launched this feature and we can now design this in a better way.
And I believe eventually it will not be just the initial design phase, maybe later on that my existing design also it can be checked, and then maybe some recommendations can be made or something like that.
Yeah, exactly. Yeah.
Yeah.
Perfect. So, okay, so I think we have a link to the MCP. So, Jeff, if you can just share it with our viewers as well, that would be great. Okay, so behind the scene or under the hood of this solution, can you just give us more details about it? What happens behind the scene, how it integrates, how it generates those design patterns?
Yeah, I suppose when walking through the demo, we'll see it in action a little bit better. We'll show you a demo in a
Perfect.
second, but for now, basically, when you install the MCP server, the whatever agent that you're running on will be able to see that or discover that tool that's part of the MCP server. That is the data modeling tool. When your AI agent realizes, hey, you want help with a data model, then we it'll pick up that tool automatically. And from that tool, then it will actually just reach out to the context that we've pre-created that holds that, years and years of DynamoDB expertise, and it will start to steer through the data modeling journey with that. And you'll see from the demo again that we create two files. One's a requirements file. So the AI must go through all of your requirements and it must checkpoint specific things before it can move on to actually exploring a data model. That's things like, did you cover all your access patterns? What kind of scale are we talking about? Are we talking about large scale, small scale? How many requests per second? And then it will help you understand, is there any, did I notice, is there any missing access patterns? Maybe you have access patterns about a user getting some things, but you never actually created a user. So it might prompt you to say, hey, you're talking about users. Do you want the ability to create a user? So it goes through all of these steps. And when it's finally satisfied that it's got all of the things that it needs to have in place, it will design a data model for you. And again, that data model is then iterative, that you can ask it to change things should you wish and things. So you can think of the whole thing like it's like guidance. It's not
Mm.
going to say, hey, you must use this. You can talk with it in natural language and you can start adjusting things because maybe you notice that, hey, I don't actually have that attribute, but I have this attribute. Can you, change my data model to suit? So it's
So,
very flexible that way.
yeah, so it's similar to the conversation that you usually have with your customers. This is usually the questions that you are asking them, and then based on those answers, you start um, guiding them through the solution itself or the design pattern.
Yeah. Exactly.
Perfect.
Anything
So
to add there, Kevin, before we move to the demo?
The only thing I'll go ahead. Sorry.
yeah, I'm sorry. I'm just going to say that. Yeah, Jeff is now has shared the link to the DynamoDB MCB server that we've been talking about, so you can check the documentation and the code of the server. Okay, back to you, Kevin.
Yeah, I was going to say, just to add to what Lee said, is, as I mentioned earlier, it really is, when you're having a conversation with your AI agent, it's aware of these tools that it has access to through the MCP. And so in the context of data modeling, it goes and calls the tool, and really we just inject this how-to guide into its working memory, right? And that came from a lot of iteration, learning from Lee and other specialists, like how do we talk to customers, what are the things that might trip us up whenever we're modeling data, and going through that flow hundreds and hundreds of times with AI agents to find where we can point them in the right direction. So yeah, it's been exciting. It kind of seems simple, but there's a lot of effort that went into that.
Perfect. Okay, so I think maybe we're ready now for the demo.
Yeah.
Sure.
Cool. Okay, so I'm going to install the MCP on Amazon Q. To do that, I created this .amazonq directory in my local project. You can imagine this is your project. You can also do this in the chat interfaces for Amazon Q and Kiro or whatever it is that you're using. You can create this .amazonq package in sort of where your AWS credentials and things live, and that means it's globally available. But what I tend to do is I like to add these things into each package, so then I can, choose certain MCP servers for certain packages so that they don't get confused when you're discovering them or which one the AI needs to choose. So this is what I do. I create a simple directory within my project, and I call a file called mcp.json. And then you can just go over here to the GitHub page that we just shared, and we can just copy this install JSON. And I just simply paste that in there and save it. And when I'm done with that, I can just start a conversation with Amazon Q. For me, I use Amazon Q in the command line. I know a lot of people prefer to do the chat interface. For me, I like the command line. It's just, it's a personal preference, but it just seems easier. And
So
we'll
is it just basically just like that? You add this JSON file and that's it.
Super simple.
That's amazing.
It's picking it up from here, and when it's installed, you'll see that it's initializing here. It's just installing that and compiling that library. There's nothing else going on. We have some things that we can set. You need UV installed. That's one of the prerequisites for all of the AWS MCP servers. We have this flag that's read only, which you can set to true. We have the profile, or AWS profile, or AWS region. In future iterations,
authentication.
Yeah, in future iterations for the data modeling, this is not needed. So the previous version, which I am using here, also done the DynamoDB CRUD APIs. So create a table, delete a table, update an item, create an item, and it needed this permission to do so. Those are now going to be incorporated into the AWS MCP server. So AWS is like what we call an all-up MCP server that has all of the CRUD operations for all of the AWS services. So we're going to remove the CRUD operations from the DynamoDB specific MCP server and move that into the AWS MCP server where it already exists. So we don't need your credentials any further. We want this MCP server that is kind of, right now it's data modeling. We want it to be totally for the developer experience. We're going to focus on data modeling. Kevin can maybe talk to, maybe once we show the demo, Kevin can maybe go over some of the things that we're thinking about in the future. What kind of capabilities we think that we can introduce through this MCP server. But for now, it's just the data modeling.
Yeah, I was just going to ask if the output from this tool can be fed into the AWS API, MCP, and then it can create the tables for you and everything.
100%, yeah. So like here, I've just got the DynamoDB MCP server, but if I had the AWS one installed here as well, it can actually do that. So it can create the tables, it can add the sample items for you. So yeah, you can mix and match your MCP servers.
Okay, that's great.
Yeah, we can definitely talk about that once we get through the demo. So it should have installed it. So if I list the tools, you can see here is the MCP server that I just installed. You can see I'm using the older version, so it is
Lee, if you can open the terminal in a new window, if it's possible to do that.
Open the. I think it is.
To the entire, yeah. And
Is
if
that
you
better?
can zoom in a bit, that would
Yeah.
be great.
I think that's probably
Perfect.
as much as I can get.
Okay, that's perfect. Thank you.
Okay. So yeah, we're just these are the CRUD operations that I said that existed in the DynamoDB data modeling or in the DynamoDB MCP server. Moving forward, it's just going to be this data modeling one for now. So the DynamoDB data modeling is the one that we're interested in. It's the one that's going to help us design a data model. So if I, for example, just say, hey, can you help me design a data model for DynamoDB? Okay, so I'd be happy to help you design a data model, blah, blah, blah. And it's going and it's discovering the DynamoDB. Yeah. So it knows straight away which one is required for that. So it's going to ask us, are we happy running it? You can use T in Amazon Q to trust the tool, meaning that never asks for your permission to do something and it just does it. I like to use Y because I can see every change that it's trying to make. Okay, it's just invoking it. So right now the MCP server is calling that tool, and that tool is reaching out to the context that we've defined within the MCP server. So it's going to say, let me start by understanding what application context. So it wants to know a little bit about our application. So I come up with a sample application that is for concerts. So it's get all upcoming concerts by city, get concerts by artist ID, and so on. You'll notice that the first thing we think about when we're designing a data model for DynamoDB is your access patterns. This is where it differs slightly or a lot compared to a relational. You really care about your relationships and modeling, your primary keys and foreign keys. This is a little bit different here. We always think backwards from our access patterns. So if we go ahead and take the access patterns that we want and we tell the tool, it's hey, it's
Really, it's wanting to create the requirements file, so it's asking for you to trust
it
it
is.
to do that.
Okay.
Yeah.
Sorry, I'll definitely do that first. So it's like I said in the beginning, it creates two files. One's the requirements file that it must checkpoint through to make sure that it has all of the requirements. The second is the data model, which is the output that we're looking for. So we'll allow it to create that file and we'll preview that in a second.
Okay.
And Lee was talking about, CLI versus like using the IDE. I'm split. I bounce between the two. But in this particular example, I like keeping the requirements file like in preview mode in the IDE because you can watch the AI agent filling out the requirements as the conversation's going on.
See, okay.
Besides that, I think I'm in the CLI like Lee.
Yeah. Cool. So we give it our access patterns. It now understands that it's a concert application with artists, users, followers, tickets, and so on. And it now needs to gather the RPS estimate. So it's going to ask you about your scale. So first, we're going to let it update the requirements gathering. And then I am going to grab the scale that I came up with, which is a really good application. I wish it was mine. 5 million users, 1 million monthly active users. Peak concurrent users is 100,000. Top artist followers is up to 500,000. Average user followers is about 20. Ticket purchases per day is 50,000, and the peak purchase throughput is 2,000 writes
per second.
Per second.
Wow. Okay.
Okay. So I'll go ahead and give it my scale. Okay, so it's added the scale information. So it's going to update the requirements file with the scale that we just added. And then after it's done that, I'm going to show you the requirements file. So just that we know what it's made up of. Good. So let's preview this. Is it still readable?
A bit, yeah.
Let me see if I can make it a little bit bigger.
Are you okay? Yeah, that's better.
Cool. So some application overview. We have, it's a concert. We know it's a concert ticketing system. Some of the entities that it's gathered from the access patterns that we had. Business context. It has fan out notifications, ticket sales tracking, search functionality, and popularity metrics. Something about the scale. So then it's going to go through the access pattern analysis. So you can see that the status is still kind of still working on it. Get all upcoming concerts by city, filter by future date. We can see the estimated RPS that it has for that particular access pattern. It's a read type, the attributes that it needs, and the key requirements. So it wants less than 100 milliseconds and to allow for date filtering. And then it's design considerations, saying it needs a GSI or a global secondary index on city with date as the sort key. So that will fulfill this access pattern. If any of these,
Lee, I'm starting to see what you were referring to when you said that start with the access pattern first, and then the design will come. So I'm starting to see that now.
yeah,
It's different from the relational database, definitely.
yeah. What do you see when we get a little bit further, when it's trying to figure out how to store the entities? Do I store them together, or do I store them in separate tables? And that's where it gets really fascinating. So if any of these numbers that don't align with your application's needs, you can just tell it and say, hey, it's 100 milliseconds. Maybe you want, hey, I want it to be less than 50 milliseconds. Or the RPS here is 500 or 100. Maybe it needs to be, I don't know, 1000 and 300, whatever it is. You can adjust any of these at any time.
So do you adjust them directly in the file, or
No, you just tell the
Okay.
in the chat, say, hey, for this particular access pattern, I need more scale.
Okay.
It's made an assumption here based on the number of users and or peak, and it's kind of just went and tried to figure out, well, which of these are the most popular, and I'll divide that sort of request or RPS out between all of those.
Lee, can I add something to that? So I think, going back to the conversation earlier about saving customers time, ramping up using DynamoDB, even something like this where we're making some assumptions, but we're laying it out in a framework that we know works well. Now, visually, you can see this and say, oh, okay, this is how I should think about it. I should understand my access patterns. I need to know the RPS, and that, we think, just alone can help accelerate learning to use the database.
Yeah, totally agree.
Exactly.
So it's saying here that every access pattern must have the RPS documented. So having the amount of throughput you need per access pattern is a very important component of data modeling in DynamoDB. Where the data should live, what size the data is, and things like that. All of those have a really significant impact on how you model the data. Some of the relationships that it's come up with from the input. So a user has many followers, artists has many concerts, a user has many tickets, and a concert has many tickets also. So then it's coming here then with the item collection analysis. So it hasn't gone through all of this completely yet, but this is where it's trying to figure out, how does it denormalize the data? Which entities need to live together, and which entities are fine as their individual own tables. So it does that. It's determined by how you access the data, and we'll see that as we go through. We'll keep talking with it, and we can see that.
And one of the Lee, I was going to add, one of the things that's interesting about this part here is that we're in this requirements file. We haven't generated a data model yet, right? But under the hood, what we're doing is we're telling the AI agent, we want you to treat this file like a notepad. Just start writing. We want you to write down what the user is saying about their access patterns. And then there are certain things we want you to write notes about, like this denormalization section or the table consolidation. We want you to start to write notes about these, because what we find is that now when we go generate the data model, these notes that we force the agent to write actually get closer to the data models that we want it to generate. And so every time you go through this flow, you're going to see it writing these same sections of notes.
Amazing.
Yeah. And like Kevin says, when I'm doing this on my own, I usually keep this requirements file opened on one side, and then I talk away with it in the CLA or in the chat interface, and you can see it changing in real time. And you can keep an eye on the things that it's identifying, so that you know, hey, maybe you got this thing, it's different than what I wanted, or maybe you kind of get learnings from it as well. It's like, oh, I didn't even think about that one. So it's quite good to watch this file as it gets created and iterated on. Cool. So let's go back to the terminal and see where we're at. The last question that it asked us: do you also need patterns for creating, updating concerts, artists?
Please, sorry. Before moving on, we have two questions actually from our viewers. It has some parameters to execute on the local stack.
Not just yet. That is something we'll talk about what we're working towards after the demo. Kevin can take you through that, but that is something we're working towards. Local stack uses DynamoDB local under the hood, and that is something we're planning to integrate with this data model and MCP server.
Perfect. Thank you. And also a question from Schizophrenic Web Developer: is duplicating data in DynamoDB bad?
It's definitely not bad. It's not like a relational database where you try not to duplicate data. In DynamoDB, you denormalize the data, which means yes, you can have duplicates, but there is also a fear of over duplicating. For example, let's imagine that you had e-commerce is usually quite easy one for everyone to understand. You have an e-commerce app, and for example, in every order of a user's order, you place their address, and then the user decides that it's going to move address, or they're going to move address. So now you need to update every order that user has ever placed with their new address, rather than having it in a standalone place as a single item, where it means you only have to update one item. Address is probably not the best attribute to change, but you get what I'm saying. If you denormalize too much and you put too much duplication in, and then if that's something that can update in the future, do you potentially have to update then, hundreds or thousands, maybe even millions of items? That's when you want to avoid that, and you would bring that up to its own item, where you only have to update one of those rather than 1 million.
Perfect. Thank you.
I hope that answers the question. Cool. So we need to gather. No, we did that. What's your expected scale? We've done that one. I know we're in the wrong question. So this is what I said, where it kind of gets a little bit inventive, where it's like, hey, I noticed your access patterns, but do you also need to be able to create, update concerts, artists, or are those admin only operations with low volume? I'm just going to skip, and I'm going to say no, those aren't required for now. But you can obviously, say yes, they're required, or maybe they are low frequency, that they don't significantly impact how the model or how the data should be modeled.
Yeah, one of the things I found fascinating about this, as Lee and I and others were working on it, is we really can steer these AI agents just through prompting behind the scenes like this to tell them these are the things you must do. Like every time you have to do this, or every time you output this file, it needs to match the structure, and you can get it very close to doing it every single time.
See.
So it's asked me, do I want to discuss anything else, or should we just proceed to the data modeling? So it's just going to make the last final updates to the requirements file, saying that it's pretty much satisfied with how the conversation went. It's got enough of the requirements fulfilled. And yes, please. I don't know why I'm so polite with these LLMs.
So nice,
please do this, and thank you. Yes.
There's a study, and you know what? I have to admit, I haven't read the result, but somebody studied this. It's like, if you're polite to the language model, will it give you better results? I should go. It's on my reading list. I'll have to go check that.
I love to know. Yeah.
It's like maybe Lee's getting better results than me.
But it means more GPU cycles, I believe.
Yeah. Please.
So
thank you.
Also, we have a question from Tiger Panda does the MCP gives recommendation for permissions? For example, if we provide cognitive group names.
Yeah, in this sense, this MCP server just runs locally on your own machine, so there's no permissions required. It talks to the LLM, or if you use an Amazon queue or whatever, and that's where your permissions is based, or whatever other LLM that you're using. So the MCP, for the data modeling specifically, it doesn't need any permissions at all because it runs on your local machine.
Okay. Oh, okay. Is that, are we here talking about the permissions to run the model or permission for running the solution itself?
With to actually run the data model in MCP. So yeah, there's no permissions required for that at all.
Yeah.
But you will need permissions, obviously, to talk to
Exactly.
whichever LLM or agent that you're using.
Cool.
Cool. So let's see. Open and preview. Close the terminal.
Yeah, I think this is a follow-up for the previous question. For example, could you restrict a table on DynamoDB to only admins?
You can do that. I mean, it's a little bit outside of the scope of the data modeling, but you can for sure restrict tables with resource-based policies, IAM permissions, and things where only certain people can access that table. Yeah, that you can do that for sure.
Can I give an example? Maybe so. Let's Lee talked about this earlier. Let's imagine that we have this data modeling MCP server installed, and then we have the AWS API MCP server installed. And we get through the end of the data model and we say, hey, can you deploy this for me? So now, your AI agent is going to call the AWS API MCP server and try to deploy the data model. And within AWS, you could have restricted who can actually create those tables. And so the user trying to do that deployment might not have those permissions. Maybe they're not an admin, so they're going to get rejected whenever they do that.
Yeah.
Perfect.
Yeah. So yeah, if you've seen from the JSON that we have here, we have the profile. This is the same as what you will see in the AWS MCP server that would be creating your DynamoDB tables and things. And based on the permissions that you have for your AWS profile, will determine what capabilities you have to do. Do you have permission to create a table? Do you have permissions to add data to it and things like that? So these are all handled by that.
Perfect. One quick question. Does Amazon Q run on Windows computer?
It does. It does, yes, for sure.
Okay, perfect.
Cool. So this is the output. It's talking about an aggregated orientated design. And basically what that means is that there's a high correlation of entities. So user and followers together is 60% and user and tickets together is 80%. So we're going to use item collections. An item collection in DynamoDB is basically all data related to a given partition key. So in DynamoDB, we've got a primary key that's made up of a partition and optional sort key. If I have a partition key, for example, user ID, and I've ordered many tickets so that the sort key may be ticket ID. So I could have, 10 concerts, for example. So I'll have 10 individual items related to a user ID. That's an item collection. So I can tell DynamoDB, hey, select star from table where user ID is equal to Lee, and it will give me my 10 tickets in a single request. And that's the power of an item collection, where you can make these requests as a single request using what we call the query API. So this is important because this is how it's modeling the data to make those requests so that you can look them up in a single request. That gives you that low latency that you come to expect with DynamoDB, so long as your data is modeled in the right way. So this is basically a little bit of a philosophy where it's telling you why it's doing these things. It gets into more about specifics of why it's combining and how it's combining them. So it'll actually give you reasons why, for example, two entities live in the same table rather than having a table per entity. And then you'll also see that maybe some tables will have, just a single entity on it because from the access patterns that we've defined, they you don't group them in the reads. So for example, maybe a user and a concert venue, they might be two completely different entities that are never read together, so they can live in separate tables as their own entities. So if we go down here, we're looking at our tables. So the first one is the user followers table. So we have a user with a profile. So we have all of the user information in there. It's given us an example here that's the email address and when it was created and things. So you'll notice our partition key is user ID and our sort key is here. It's called profile. In the same table, we also have the followers. So we have user123 again, and we have follow, hashtag, and the artist ID, and the artist name, and the follow date. So what we're saying here is this is an item collection for user123. They have a profile, they have two followers, or they follow two artists, which is Taylor Swift and Ed Sheeran. So when I want to look up a user's profile, maybe I want to see who they follow as well. I can just say to DynamoDB, hey, in the user followers table, give me everything for user123, and it will get these three items back in the single request. So I have the profile plus both their followers. Now, if I only want their followers, I can simply say, hey, the user ID is 123 and the sort key begins with follow. Now I can just get their followers. And likewise, if I want to just get their profile information, I can say, hey, get me the item where user ID is 123 and sort key is profile. So what that makes up an item collection. We can see we have another user here with an example profile, an example follower. So then we
Lee,
yeah, go ahead,
I was
Kevin.
going to say you were kind of touching on this earlier, where you have to design it after your access patterns, right? And so you, in this case, you've got one item collection that can solve multiple queries. But if you didn't know where you wanted to go to begin with, then you wouldn't know to group these things in that way.
Exactly.
And I think that's the powerful thing. To your point earlier, like with third normal form, you start with just your data, you follow three rules, and you have a data model.
Yep.
Here, yeah, it's powerful.
Yeah, totally agree. So it gives us some more information then about why it's decided this. So it stores the user profiles and the artist follows in a single aggregate user entity and follows for that user, which identifies the relationship. Given us the partition key, it's telling us that it's high cardinality. We have 5 million users, we have a good application, and it's even distribution. And that's what NoSQL database is like, even distribution across what we call a key space. So if you have nice even access patterns, then you can scale basically to infinity. Sort key here sends profile for the user data and then follow hashtag artist ID for the follows, and it enables querying for user and their follows. So we just seen that a second ago. Some of the attributes, some of the bounded read strategies. If we move on, then we have follow by artist GSI. So we have a global secondary index on that table, and the artist ID is the partition key. So if you imagine your web UI or your application where you click on an artist and you want to see all of the users following that artist, this is what fulfills that access pattern. So artist ID is a partition key, user ID is the sort key. Purpose enables querying for followers by artist for pattern number 5 that we mentioned, and it is also used for notification fan out. So if an artist, for example, has a new concert coming in, I don't know, December, whatever, and you want to notify all of their followers, hey, there's a new concert for your artist. That's quite useful. So not to go through every one of them in too much detail, but you can see that it gives us sort of...
just wanted to give you a heads up that we only have 9 minutes left in the show. So yeah.
So it kind of gives us an overview and why it's done things for every single one of our access patterns. And then you'll see at the end, it will actually map out the access patterns that we give it. So get concert by city. So we're going to query the GSI with city date as the partition key. Get concerts by artist, query GSI with the artist ID as partition key. So for all of the access patterns we provided it's mapped it out here and how we do it. So which is the entity? So concerts or concerts by city GSI. User followers table followed by artist GSI. So it will actually tell you how to fulfill each one of those access patterns and actually which attributes that you need to provide to get that. Here's another important component of this. So, I mean, it's not trying to force things in DynamoDB that don't belong. Search concerts, if anybody that has used DynamoDB, we know that it's not used for search. DynamoDB is used for, OLTP, high throughput, low latency. Search is not one of the things that we're too concerned with, that it sort of breaks the mold of why DynamoDB. So here it's saying that, hey, this use case needs search. I think that, OpenSearch would be a really good, kind of service that can accompany this data model. And for that, you can use the zero ETL integration from DynamoDB to OpenSearch, and then you can be able to search directly for those concerts. Maybe you only want to search on the concert description or the concert name, whatever it may be, and then you would go back to DynamoDB and get all of the details of that concert, including how to purchase tickets and things like that. So it's really good at that. It's not trying to force search. Like a search in DynamoDB would be a scan plus a filter, which can become really inefficient at scale.
Perfect. So I think the question would be after that, if I used the MCP for this and it created a model for me, how can I evaluate the output from this from the DynamoDB MCP? How can I show that it's accurate?
Yeah, I'll pass that one to Kevin. He's the roadmap guy.
Yeah, I think that kind of gets into exactly that question of where we want to take this. So, we kind of see this if you're a developer and you use AI agents for coding, you have this workflow that you get into where the AI agent, it generates some code, and then you as the developer, you verify its accuracy. We want to try to create the same loop for the developer experience with DynamoDB through MCP. So, one of the things that we're looking for in the future, which we talk about in the blog as well, is the ability to actually deploy this data model, and that might be initially in DynamoDB local, if that's your preference, or to the AWS web service as well, and test the data model out, generate some sample data, actually insert it, query the data model, and then create this feedback loop where we take that information from your testing and feed it back into the tooling that we're designing so that you could iterate on the data model. Lee was talking earlier that it's a very iterative process, right? You might deploy this data model and find that one of these patterns is, 50 milliseconds instead of the 25 that you're looking for. And so if we pass that information back to the AI agent and we say, for this data model we generated, the latency is too high. How do we get it down? And then have that AI agent use the context that we use today to try to improve the performance of that, and then continue to iterate, deploy that new data model, generate sample data, and test it out. That's where we kind of see this data modeling path going, is to really give you that ability to deploy it. From there, you can envision that we create tooling that would help you actually generate and deploy the full data access layer for a DynamoDB data model, so that you could start to think about how your application plugs into that. And then beyond data modeling, there's other areas we're interested in as well. You could, if you're coming from a relational world and you're used to implementing stored procedures or database triggers, or doing an aggregation right on the fly with the query language, how do you accomplish those on DynamoDB? The good thing is DynamoDB plus other serverless AWS product services, they give you the ability to do this in a serverless way that is going to scale virtually infinitely, right? But that's a new experience to have to go create those. And so we envision also being able to explore that developer experience realm and detect these patterns that you might need to implement, and then give solutions for those as well. And so I guess you could kind of attach that to extending the data modeling capabilities that we have so that we can support these other advanced patterns. But that's where we see it going. This is open source. We would love contributions, but internally as we talked about in the blog, we do have some other things we're working on to roll out.
So what kind of contributions we are asking our customers to do, or our viewers?
Yeah, I mean, use your imagination. We love, anything that you think that other users could get value from in terms of the developer experience. Should you want to enhance the data modeling output? Should you want to, for example, add a completely new tool that you think users will really like? So we're open to all types of contributions. Yeah.
Okay,
Yeah.
so I'm sorry. Go ahead, Kevin.
Yeah. I think to add to that, imagine you use our tool and you try to design some application and you realize, like, you know what, actually, there's a better design pattern to be had for this application scenario. Tell us, open up an issue and describe your scenario. Help us enhance the data modeling logic. Yeah.
Perfect. So this is for all viewers, all the users of the tool. If you have any comment, any feedback, please let our guests here know about it, and they will check them, and if they are valid, they will incorporate it into the tool itself. And yeah, I think by that we've reached the end of our session today. Before we end, we have just comment from yeah, just being polite to the model is nice, but promise to tap $1,000 is really good answer.
I think being polite is tipping them $1,000 because you're using more tokens when you're adding those extra niceties.
Yeah, perfect. That's a nice tip that we will try later. And Schizophrenic is asking, is Lee the author of the serverless development to an AWS book?
No, it's here because I really like the book. It's in my background. I'm guessing that's why they're asking. But no, that's by Sheen and a guy called Luke Hedger. Really good book.
Okay,
Highly recommend.
perfect. And another comment, the NoSQL Workbench app seems kind of deprecated after this. Thanks for the showcase, guys. Thank you so much. Thanks for all of
for
our viewers.
NoSQL work. So you run. Sorry, just on the NoSQL Workbench
Yeah,
side of things, we are probably going to incorporate some of the AI stuff that we're building through the MCP into
perfect.
NoSQL Workbench to kind of give you that full kind of cycle of how to model data and visualize it and things like that.
Perfect. Thank you so much. And at the end of the show, thank you so much, Kevin and Lee, for the share today. Thanks for joining us, and thanks for this informative session. And for all our viewers, thank you so much. We'd love to see you again next week, same time. Next week we'll be discussing about designing real-time data architecture patterns for AI agents. So I'll be waiting for you 5 p.m. CET, 8 a.m. PT, and 11 a.m. ET. Thank you so much, Kevin, Lee. Thank you so much.
Thank you, everyone.
Thank you.